You know, after a long day of work, it's nice to unwind with a glass of something cold and sweet, and maybe a bit of alcohol for fun. Apple cider is a great day ender during the late summer months, and depending on the apples you use, you can really play with the flavors for a more tart or sweet drink. You can also ferment it to make hard cider or apple cider vinegar like I'm trying to do, which has numerous health benefits, of course, because you can use the acetic acid as an ingredient to make aspirin. Let's start with the apple cider. I'm using 72 apples to make about 7 liters of apple cider today, so feel free to scale down if you want. For ingredients, I'm going to follow the Do-It-Yourself Bible, Emery's Encyclopedia of Country Living, which suggests getting a mixture of apple varieties and ripeness to produce a more interesting and layered flavor profile. In southern Ontario, like where I live, you can wait until the fall, October, November season when apple farms let you pick from a wide variety of apples in season. But you can also grab the more typical kinds which are offered in stores year-round. For this recipe, I'm using about 3 kilos of young Crispin, also called Mutsu apples, about 1 kilo of ripe Jonagold apples, 3.8 kilos of young Crispins, and 3.8 kilos of young Jonagolds, making a total of 11.6 kilograms. A person picking by hand might be able to pick this many in about 12 minutes. Our goal now is to break these apples into small enough pieces that we can juice them. Traditionally, apple cider is made by putting the apples through a mulcher called a scatter and then pressing the chunks between mesh cloth in a press, and this is still the way it's done today. However, I don't have any of that stuff, so I'm just going to use this juicer I have here. Cut the apples into small enough pieces for the device you're using. I found that a good technique when using a knife is to use a claw grip and twist the blade a little at the end of the first cut so that the half of the apple lands flat side down and doesn't roll off the cutting board. Also, since we're juicing these, there's really no need to remove the skin, stems, or cores. People 100 years ago didn't do it, people today don't do it, and if you're worried about cyanide from the seeds, measurements report that there isn't enough concentrated here to do anything bad to your health. If anything, any benzaldehyde in the seeds will only add to the flavor. Once you've broken down all your apples, you just put the pieces through your machine and you're pretty much done. After 1.5 hours of chopping and 2.5 hours of juicing apples, my final yield of cider is 7 liters plus minus half a liter, which represents a volume to mass yield of 0.60 plus minus 0.05 milliliters of cider per gram of apples. I also used the hydrometer to take a density measurement and got 1.052 grams per milliliter, which means I get a mass fraction yield of 0.63 plus minus 0.05 grams of cider per gram of apples. What's great about apple cider over juice is that cider is unfiltered, and those little pieces of apple that get left over in the cider add to the flavor profile and texture of the drink, giving a kind of creamy mouthfeel that, in my opinion, is hard to beat. Okay, it's 140. Alright, bottoms up. Sweet like I expected. Actually, I was thinking it wouldn't be that tart, but this has just about the right amount of tartness. Those Crispin apples were really the right idea. Oh yeah, that's really good. Maybe I'm just thirsty, but yeah, pretty good apple cider. Alright, so if that's all you want to make, this apple cider is done. You could just drink all of this, but I'm going to leave this to ferment, and we'll go on to the next part of the experiment. So that's it for the cider. Now let's continue on to make apple cider vinegar. The process here is a double fermentation where yeast converts sugars in the cider under anaerobic conditions into carbon dioxide and ethanol. Then, acetic acid bacteria convert the ethanol under aerobic conditions into water and acetic acid, which is vinegar. Nowadays in 2021, fermenting tanks like the Frings reactor, as part of a multi-stage so-called acetator system, are used which blow a steady stream of oxygen up through the bottom of the reactor, producing a strong 5 to 10% by volume solution of acetic acid over a 30 to 40 day cycle. Of course, I don't have this equipment, so I'm going to be using a millennia-old process where I fill a container half full of cider and cover it with a semi-permeable lid. This is called the Orleans process in the literature. If you want more details on modern vinegar production, the must-read resources, in my opinion, are Lee's 1989 article on cider vinegar, and this gives the Western English perspective. Also check out Emda's 2014 vinegar article in Ullman's Encyclopedia of Industrial Chemistry, which gives a more international view of the technologies behind vinegar production. So you'll notice here that I have the cider in a tank more than twice its volume, and that's going to allow a lot of oxygen to stay inside the tank and keep the acetic acid bacteria happy. The tank is equipped with a loose-fitting lid so that gases can go in and out, but bugs and dust stay out. Now, remember the density measurement I took earlier? We're going to use that number to track the progress of our fermentation. According to the theory, the yeast are going to eat the sugars inside here, which are heavy. As they do, the solution will become less and less dense. If the density stops decreasing, that means they've stopped eating, and the vinegar is ready. So we'll keep that starting density I measured earlier of 1.052 grams per milliliter in mind. Now I get the fermentation started. Yeast and acetic acid bacteria exist everywhere on plants, so there's probably a lot already in this tank. But just in case the juicing process damaged them, I re-inoculate the cider by getting an unwashed apple and ladling some of the cider over it. Now we wait. The first stage is the alcoholic fermentation stage. I leave the cider alone for 1 week to restrict the flow of oxygen and allow the yeast to produce some alcohol. I'd like to mention at this point that if your juicing method produces a lot of foam, you probably want to skim that foam off. Otherwise, the top stays stagnant and some mold can grow like it did here for me on day 6. That's okay, I just scoop it out and throw it out onto my lawn. The cider is about to get stirred and acidified beyond survivability, so any mold spores that remain here aren't going to get a chance to re-establish themselves. The vinegar basically cleans itself, and this is what is meant when people say that the vinegar production process is auto-sterile. Every day for the next 2 weeks, I open the top of the tank and stir the cider vigorously with a washed spoon for 5 seconds. I also use a fan to evacuate the built-up carbon dioxide and introduce some fresh oxygen. In the Orleans process, the fermentation to vinegar is primarily a surface phenomenon, so we need to keep the air gap above the cider nice and oxygenated. On day 18, I noticed the cider taking on a vinegary odor. I also saw the cider bubbling a little from the yeast making carbon dioxide. These are all good signs that the bacteria and the yeast are working together. A few days after this, I saw less bubbles and nothing much going on at the surface of the cider. Fermentation is starting to come to a close, and at this point you're going to want to take a density measurement every 3 days. When you see 2 subsequent measurements giving the same reading, the fermentation is done. After day 18, I decided to stop stirring the tank and allow it to sit alone for 3 more weeks. This will allow an anaerobic environment to develop again so the yeast can produce a bit more ethanol to keep the acetic acid bacteria going. On days 39 and 40, I saw the typical layer of solid stuff floating on the top instead sink down to the bottom of the tank, and I took this to mean that any bubbling from the yeast had stopped or that the amount of alcohol and acid in here had suppressed whatever yeast and bacteria were growing on the surface, and now I was really done. I take a density measurement and record that it has fallen to 1.000, and I interpreted this to mean that the vast majority of the sugar is gone. Ooh, that changed a lot, I think. Gee. So, after 43 total days of fermenting, this vinegar is done, and let me tell you, it smells amazing. Okay, I am gonna grab 32 grams worth of this to try. Again, it's kind of sour smelling. A lot less than if it was pure vinegar though. Okay, bottoms up. Oh, that's super vinegary. This is really good for the project. But that is not very pleasant. This is not, you wouldn't want to drink this. It's not like wow, this is just like a kombucha. No, this is a vinegar. You know, the aftertaste is quite good. It's kind of like a salad dressing. expected, but man, I was not expecting this to work out that well to make vinegar. Man, I don't know if what I want to do with this now. I don't know if I want to drink it. At this point, you can filter off however much you want from the tank and store it in a bottle like I do here. This stuff will be great in sauces or marinades owing to that complex flavor we achieved when we first made the apple cider. And, of course, we can also use it for health, as a disinfectant or to make aspirin. But not for bodybuilding or weight loss. I don't really see how that would work. As a final quality check, we can compare the acidity of our homemade apple cider vinegar to the store-bought varieties. However, being dilute solutions of acid, pH papers just aren't going to be precise enough for vinegar, so I'm going to use a glass membrane pH probe. This thing is super precise. It's able to measure to the 3rd decimal place for pH, but there's a few things to keep in mind when you use it. Keep the solution circulating around the glass bulb, but make sure not to let anything hit the bulb because that will impact your readings. Rinse your bulb with neutral water and pat dry after each new sample. Then, submerge in the sample for 2 minutes to allow the readings to steady out. Even after you do this, you'll notice that the readings jump around a little bit. Which number do you write down? One way to get around this problem is to assume that the jumpiness is due to random noise. Take the last 10 to 14 seconds worth of measurements and take the pH to be the mean of these readings. Because we assume the jumpiness to be due to a random process, we can interpret the mean to be the true pH value, and any readings varying around this mean to be normally distributed. Just to quantify our confidence in this value, construct a t-distributed confidence interval around each mean when you record your data. When I did this, I found that the store-bought white vinegar I had a pH of 2.513, the store's apple cider vinegar had a pH of 2.744, and my vinegar had a pH of 3.188. Assuming that all the acidity comes from acetic acid, a pH of 3.188 corresponds to a 0.139 volume percent of acetic acid in this vinegar, which is definitely not consistent with the industry literature values for apple cider vinegar as reported by Emda and Leah, nor with the 5%, which is typically sold in stores like I have here. Right now, I don't have any theories for why this is, but it's interesting to note that my measurements suggest that the store's white vinegar has a 3.1 acetic acid by volume percentage, even though the label reads 5%. So there could be some bias in my measuring device. If you're interested to see how I reason through the calculations for converting a pH value to a percent acid value, and how to use statistics to get a value from a noisy measuring device, I have 2 upcoming videos explaining this. Not only do I provide a step-by-step guide, but more importantly, I show what I think is a much better way to approach science and engineering problems. The links to these 2 videos will be in the description. Okay, I'm back, and now we're gonna try all of these vinegars. I thought I would do this at the end, just to see how my vinegar compares to what you'd buy at the store, and some plain white vinegar. So, I've also got some water and some crackers here so I could cleanse my palate. And let's just start with the white vinegar as a control. So this is just pure acetic acid diluted in water. Let's give this a try. You know, it just smells like vinegar. Oh, that's so sour. God. Yeah, the pH was off by like 0. The pH difference between my vinegar and the white vinegar is 0.4. So, I mean, pH is not linear. That's a logarithmic base 10 scale. 0.4 is a lot, and man, that's sour. It has a very neutral flavor. This comes from wheat malt that's been distilled and then aerated in the Fringes reactor. So, or in the Frings reactor, sorry. So, this could get pretty sour, and you don't really get very much of that wheat flavor. Maybe at the end you could convince yourself that you do taste a bit of malt left, but no, that's just vinegar, and that is sour. Man, okay, I just took a little sip of that and still so overpowering. Okay, moving on, let's try the store-bought apple cider vinegar. You can already see, just compared to mine, color-wise, it's a lot darker than mine. Maybe there's less water in it. Well, there's definitely less water in it. It's more concentrated acid. But maybe they actually remove some water from it to get it that color. Or maybe the apple particles have been oxidized, so it gets a bit darker. It has that sweet apple cider vinegar smell. It's just, you know, if you've had it, you know what it smells like. Let's give it a try. Okay. Still very sour. Now what I notice is that despite both of these being 5% on the label, 5% acetic acid on the label by volume, this tastes a lot less sour. And it could be because there's some of that sweetness from the apples that's left over. Maybe that mellows out some of the acetic acid. Oh yeah, definitely less sour tasting on the tongue. Water actually tastes sweet by comparison after having the vinegar. Man. Okay, let's have mine. Still very sour, but on comparison to these two, you know, when I tried this during the density test, when I take a little swig from the hydrometer afterwards, I thought this was by itself very, very sour, but it's actually a different type of sourness than from the vinegars that you'd buy from the store, the apple cider vinegar and the white vinegar. This definitely tastes more like you just squeezed the fruit and it's just like a more sour fruit. So I think the pH measurements make sense. The primary acids here aren't just acetic acid. It could be, there could also be significant amounts of fumaric and malic acids in those apples that, probably malic acid more likely, that contribute to that just fruity sour flavor, not that sharp biting acetic acid flavor you get just from the white vinegar alone. And I'm sniffling a bit just because it's still a bit sour. I've just been drinking so much sour stuff. Another difference that I notice is that there's also some ethanol flavor. There's definitely a lot more alcohol flavor in this than you'd get from either of these two. I think there's actually no alcohol in these two. There might be some regulations or standards that the industry follows just to remove all of that before it gets out of the factory. Maybe they convert it all to acetic acid, or they sort of lightly boil it off. But this definitely has a lot of alcohol flavor in proportion to the vinegar flavor. It's actually one of the more significant flavors you get from this. Yeah. There's a sort of permanent markery taste in this as well. Something that's really not that pleasant. Not permanent marker. It's like an aldehyde. It's like the flavor of, it tastes like it smells. And actually, the flavor compounds are the same molecules as the smell compounds. So when somebody says it tastes like it smells, that's exactly right. Anyways, so that's my review. Biting and acerbic. Mellow and sour. Like you mixed some apple juice with some vinegar, some apple wine, and some aldehyde. Overall, I would say I enjoyed the store-bought apple cider the best. Alright, so that's it for this project. If you came here to learn how to make apple cider or apple cider vinegar, the content's over for you. If, however, you're watching this as part of the Making Aspirin from Scratch series, there's more to come, so stay tuned. This is what we've accomplished in these steps. Upcoming steps will be completed in the next few weeks. Thank you to my bronze tier water patrons on Patreon, and especially my gold tier sulfuric acid patron, John Gregorio. If you would like to support my work, check out the link to Patreon in the description below and subscribe to my channel to follow along. You can also suggest improvements to any of the steps I've done by contributing to the GitHub repository for this project. And here are all the search queries and references I used to research this video.